this is the first problem that was set for us. Why does a thing go down? This is a tube of duct tape, goes down fine, but the other cylinder demonstrated didn't. Our first guess was to go for a thick viscous liquid. This is glycerol, and if we try this, it runs down quite quickly. The next idea was to try a more viscous liquid, and this is honey, and if we roll this down, it rolls down slower, but still the same basic problem. So now we've got a jar of honey which is about a third full, and this seems to be the key. And if I let go of this, then this moves in the manner described in the video. So we think it's a viscous liquid such as honey or syrup, about quarter, third full, and this seems to work and do what we saw. Right, problem 2. What happens to the bicycle if we lift the bicycle up a little bit and I pull? We can see the wheel, put down, is going to go in a clockwise direction, which if this wheel's going in a clockwise direction, then the bicycle's going to go forward. So if I pull this and I pull it with an equal force, let's see what happens. So you're just holding the bike just enough. Here we go. So if I pull the bicycle, then we see that the actual bike goes backwards. The force I'm putting on this, because of actually the gearing, is going to be greater than the force pulling it forwards. So the bike goes backwards. Problem 3. This is all about running round a track. So if we say we've got a track which is going to be 400 meters, and what we're going to do is the first time we're going to walk around the track at, let's say, and take ourselves a time of 400 seconds. So this is going to give us a speed of 1 meter every second. Now the problem is that we want to go round so that our average speed is going to be twice that speed, which I would say is going to be 2 meters per second. So what we're after is how long it's going to take me to go round this 400 meter track to give me a speed here of so many meters per second, such that when I take V1 and this new one, V2, and I divide it by 2, I get my average, which equals 2 V1, which we've said is going to be twice 1 meter per second. So we've got 1 meter per second plus something else, divide it by 2, gives me 2 meters per second. So this number here has got to be 3, such that 1 meter per second plus 3 meters per second gives me 4 meters per second, or divide it by 2, which gives me 2 meters per second. So how fast have I got to go round this track the second time, so that I can go at double the speed, I've got to go at 3 times the speed I went when I went round the first time. Problem 4. Basically, if we've got our train going nicely forward on a set of rails, which part of this train is actually going back? Well, if we have a look at the wheel on a train is normally flanged. So if I imagine this ruler is the track, then this part of the wheel rests on the track, but the flange actually is bigger because it's holding it on. So what I'm going to do is I'm going to line this up with a number on the ruler, and I've lined this up here with 20 there. Now what happens is when this wheel turns, and I've turned it very slightly, the train has moved forward. This is all moved forward, but if we look at this edge of the flange, instead of being pointing to 20, it's now pointing to 14, showing that it's actually moving backwards. And it doesn't matter at what speed, because this will always be moving slightly back relative to the rail, not relative to the train, as the train moves forward.